right, so the first question and the fourth question, these are the two questions on your quiz that don't have any solving. It's just a verbal answer, not verbal. It's just a word answer. And you're trying to figure out when do you need common denominators and what the first step is when you're multiplying or dividing rationals. So these just have words for answers. The first one, you must have common denominators when you do what two operations only? Yes, only add and subtract. Only add and subtract. You do not need a common denominator to multiply and divide. Only add and subtract. Let's answer the last one. The first step when multiplying or dividing rationals. Anybody want to take a guess? Factor. Factor. Okay, we're out of 20. I want y'all to get those both correct. This is on the front page. This is on the back page. Get those both correct. Next, the LCD and the restricted values both come from the same place. They both come from denominators. So neither one of these questions are really asking you to solve anything. The lowest common denominator, we just look at the denominators and we have to make sure that we account for everything. And so I see an x plus 4, an x plus 3. The x plus 3 actually repeats. We don't have to repeat it. And then an x minus 1. The lowest common denominator is going to include all of those. So without repeating. This one, this one, this one. And it's not going to repeat this one. So when you see the lowest common denominator, it would be x plus 4, x plus 3, x minus 1. That's the lowest common denominator. Again, you don't repeat. Next problem. The only way I can identify restricted values, they come from the denominator, but I have to factor this first. Who remembers what this factors into? X plus 1, x minus 1. So I'm not going to rewrite everything. I'm just going to rewrite this part. X plus 1 and then x minus 1. Okay, I rewrote just this one. I factored it. To identify restrictions, they come from the denominator. I'm not even looking at the numerator. The numerator doesn't matter what's up there. My restricted values, x cannot be equal to positive 2, negative 1. I don't have to say negative 1 again. And positive 1. So 2, negative 1. I'm not repeating negative 1 and then positive 1. This list of numbers can be in whatever order. It can be in any order. They don't have to be in numerical order. So there is a chance that the ones on the quiz are not in the same order you write them down. It doesn't matter. It just has to have the same values. It's opposite. So positive 2, negative 1. It would be negative 1 again, but we don't repeat. And then positive 1. So here are the easiest 4 problems on the quiz. Please get them right. Let's get these right. Yes. This is just factoring. This is factoring, yeah. And chances are the one on the quiz looks remarkably similar. So we just reviewed it. When you see it on the quiz, make sure you fix it. And you have to factor first. All right, now we're going to go on to where you have to do some mathing. Multiplying and dividing, you don't have to have common denominators to do so. That's why we learned it first before we learned addition, subtraction. This type solves a little different than this type, obviously, because it's division, but still, this kind is a little different. What we do with this type is we first look at the numbers and we reduce the numbers first and multiply straight across. So I noticed that 7 and 14 can reduce. 7 and 14, they're both divisible by 7. So 7 divided by 7 is 1, and 14 divided by 7 is 2. And then from here, I'm going to multiply straight across. And when you multiply across, you add the exponents. So for the x's, I have 2 and I have 4. So when I rewrite it, I'm going to write 6. So I'm going to rewrite multiplying straight across. So I have 1 times 9 is 9. X, I already said, 4 and 2 make 6. And then for the y, 4 and 6 make 10. For my denominator, I have 2. And then for the x's, I have 3 and 1. So that makes 4. And then for the y's, I have 4 and 6. That makes 10. From here, I'm going to reduce. 9 and 2 can't reduce, but if it could reduce, I would reduce it. And then I'm going to look at the x's and the y's. And the first thing that stands out to me is that y to the 10th is divided by y to the 10th. What's anything divided by itself? Yeah, so these just cancel out. They turn into 1. Here I have a 6 and a 4. 6 is bigger, so I'm going to mark out the 4 on the bottom and subtract it to the top. And now I'm ready to rewrite, and my problem is pretty much done. So I have 9. X 6 minus 4 is 2, and I still have a 2 on the bottom. This is my answer, and I could identify that my restrictions, X cannot be 0 and Y cannot be 0. The next problem. It'll X, Y, Z, whatever variables you see. Correct. When it's written like this, it's obviously different. Yeah. An X, a Y, a Z, it doesn't matter what the number is written in front. It doesn't matter what the exponent is. It can't be 0. Over here, this one is divide. And I picked a division problem because I feel like if you can do division, you can do multiplication, because multiplication is one less step. So for division, you have to make sure that you factor it. This one is already factored. So you look at the denominator, make sure numerator and denominator, make sure it's factored. The denominators are already factored. This can be factored though. That's GCF. They're both divisible by 3. So as I rewrite it, I'm going to factor that numerator. But I'm also going to keep, change, flip as I do it. So the first fraction is going to stay exactly the same, except for I'm going to factor out the 3. So it ends up being 3, and then x plus 6 divided by 3 is 2. X plus 1. Change. I'm going to change the operation to multiply, and I'm going to flip the second fraction. Keep, change, flip is for only divide. That's the only time you do keep, change, flip. All right, I did keep, change, flip. I have to identify my restrictions. X cannot be equal to, and it's going to be -1, 3, -2, and then +1. You only have to check the numerator for divide problems, but I don't think I asked you to do this part on a division problem. From here, we mark out any terms that appear in the numerator and denominator, and it looks like I see some. I see x plus 1 and x plus 1. X plus 2, x plus 2. Is that it? Yep, now we're ready to rewrite. So I end up with 3 and then x minus 1 in the numerator, x minus 3 in the denominator. It's possible that I could have reduced further if there was another 3 down here or something like that, but this is all I can mark out. So the difference in multiplication and division. Divide requires you to turn it into multiply, but a multiply problem would just start out like this, and then you factor it. Yes, that's how I got the 2. We have 2 more problems. We have addition, and then we have a solving. So for addition, the only way you can add or subtract is you have to have like denominators. Right now, we do not. So I have to identify the lowest common denominator. And that's going to be x minus 4 and then x plus 3. When I look over here, I have an x minus 4. I'm missing x plus 3. So I'm going to have to multiply the numerator and denominator by x plus 3 and x plus 3. For this one, I have an x plus 3, but I'm missing x minus 4. So I have to multiply by x minus 4 over x minus 4. As soon as my denominators are the same, they both have an x minus 4 and an x plus 3. The denominator stays the same. So x minus 4, x plus 3. My numerators, as I rewrite them, I'm going to distribute in. So 2 times x and 2 times 3. So I get 2x plus 6. And then I have plus 3 times x and 3 times negative 4. So I get 3x minus 12. From here, I can combine like terms in my numerator. It looks like that I have 2 x terms. So I can put these 2 x terms together. And then I can put these 2 constants together. So if I put them together, 2 and 3 make 5x. And then 6 minus 12 would give me negative 6. My denominator doesn't change. I could also list my undefined values. They come from the denominator. So x could not be equal to 4 or negative 3. This is my answer. Over here, to solve, I have to first identify the lowest common denominator. My lowest common denominator, it's going to be x plus 4 and x minus 4. When you're solving, you're going to multiply every fraction by the lowest common denominator, only the numerator, because when you solve, you don't want to solve with fractions. Nobody wants to solve with fractions. So our goal is to get rid of the fractions. So we'll multiply just the numerator by x plus 4, x minus 4, x plus 4, x minus 4. And again, when we're solving, our goal is to have no more fractions. Nobody wants to work with fractions. So all the fractions better cancel out. So when I go to rewrite, on the left side, I'm just left with 16. On the right side, though, I still have 2 times x minus 4. So I'm going to draw a little arrow so I make sure that I distribute. 2 times x is 2x. 2 times negative 4 is negative 8. Wow, this is a nice problem that's just a simple two-step equation. What do I do first?
Plus 8.
Yep, very good. I will add 8, so I get 24. And last step. 24 divided by 2. So I get x is equal to 12. We forgot to identify our restricted values. X could not be equal to 4 or negative 4. I probably should have written them in the other order to make them make sense. This would be negative 4 and this would be positive 4. Please don't forget to check your restricted values. Depending on the version you get, one of these answers, both the answers might not work. Please don't forget to check the restricted values on the problem that you're given that you have to solve. For this problem, it doesn't matter. 12 is not on the restricted values list, so it works. Okie dokie, we are done with the warm-up. You can go turn that in along with your practice worksheet.